So this is on lithium. This is one beta hydrogen atom is treated with alcoholic pH. Then there is elimination of hydrogen atom from beta carbon and halogen atom from alpha carbon. As a result, we get alkene as the main. Since there is an involvement of beta hydrogen, this is also known as beta elimination reaction. Okay. So we are going to continue the same reaction here. It's better that if I copy this. Now, moving on, write another point here. This reaction is also called dehydrohalogenation. As hydrogen and halogen are removed from substrate. Hydrogen and halogen are removed from substrate. Right, next point. So those who have come late, this is where we have started. Please write this point. This reaction is also called dehydrohalogenation, as hydrogen and halogen are removed from substrate. Now we were dealing with elimination reaction. Okay. Write another point. Write another point. The following reagent can be used for dehydrohalogenation. The following reagents can be used for dehydrohalogenation. For dehydrohalogenation. What are the reagents? Number one, we have already seen, that is alcoholic KOH, or we can also use alcoholic NaOH, potassium hydroxide or sodium hydroxide. Secondly, we can use RONA, that is sodium alkoxide ion, in the presence of alcohol. Third reagent is very important. It's a very strong base, that is sodium amide, NaNH2. You must not remember NaNH2, but you have seen NaNH2 in the class 11 hydrocarbon chapter. Okay, so NaNH2, this is sodium amide. Sodium amide. Done, everyone? Please write next. Rate of elimination. Rate of elimination, beta elimination, dehydrohalogenation, all of these are names of the same thing, rate of elimination. Okay. Now for rate of elimination, if I look at the halogen atoms, then if the halogen atom is having greater bond length, and if the bond is weaker, that is going to be what? It is going to be faster. That's why RF is slowest, because the bond is very strong here, followed by RCl. So this is due to the larger size of halogen atom. Then we have RBr, and the fastest will be Ri. Now, if I look at the haloalkane, then 3-degree haloalkane will be fastest, followed by 2-degree haloalkane, and followed by 1-degree haloalkane. It is because it is followed by a formation of carbocation. Okay, so this is the rate of elimination. This is for the alkyl halide. This is for halogen atoms. This is when you are having the halogen atom different, and the second case 3-degree, 2-degree, 1-degree is when the alkyl group is different. Which of the following pair? Will show faster beta elimination? Number A, you have two options. Here we have bromine or chlorine. A structure, which one is going to give the fast reaction? And in the B structures, please see. Okay. So in the A question, you have to tell me 1 or 2 which is going to give faster, and the B structure you have to tell me 1 or 2 which is going to give the faster reaction. You guys have like 2 minutes. Please send your answer in Zoom chat. No need to say the answer. Send the answer in Zoom chat to Salim, SAALIM. ये आपका लगभग आखिरी हो चुका है ना, बिल्कुल इख्तिताम तक पहुंच रहे हैं हम लोग अब. Yeah, correct. Shahid, correct. Tarif, correct. What about others? No answers from Hafsa, no answer from Mariam Khatun, no answer from Rabia. 2 minutes are over. Okay, Hafsa has answered. What about others? Mariam, tell me. Mariam Khatun. See. चलिए यहाँ पे देखिए guys. You will look at the, first of all, you will look whether we are having same halogen or different halogen. Now, in this case, first case, Br and chlorine, the halogens are different. So which one is having larger size, bromine or chlorine? So obviously bromine is having larger size. Now you have seen here, ज़्यादा rate होगा, ठीक है? So bromine is having larger size. That's why This will be faster. Okay, this will be faster. Now, if you are having the same halogen atom, here also we have bromine, here also we have bromine. Then you have to look at the degree of carbon atom, the degree of haloalkane. So this is 3 degree, and this is what? This is 1 degree. So which one will be faster? Obviously, the 3 degree will be faster. All of you got this? Yes or no? Please tell me.
Yes, I did the second one wrong.
Why? How the second one was wrong? Hafsa, your first one was wrong. Okay. See, it's very simple. Size. You have to look at size when there is when they are different halogen atom. If the halogen atom is same, look at the degree of carbon. That's it. Okay. Now write a question. This is important question. Reaction of alkyl halide gives alcohol. When treated with aqueous KOH. When treated with aqueous KOH, but gives alkene on treatment with. But gives alkene on treatment with alcoholic KOH. On treatment with alcoholic KOH, explain. Okay, so please write the answer. In alcoholic KOH, the reagent is alkoxide ion. The reagent is alkoxide ion. Which is a base, which act as base. Yeah. Acts as base due to its larger size. Due to its larger size and shows beta elimination. But in aqueous KOH, the reagent is hydroxide ion. Which is smaller in size. Which is smaller in size and acts as nucleophile. Attacking on carbon atom. Attacking on carbon atom, showing SN. Showing nucleophile substitution and forms alcohol. Okay. Please see the important point here is there are few things that you have to write whenever there is an answer. If you have short, I'm telling each and everything. Then if you have to write short answer, then you write the first time. That's it. Okay. If you don't get time, then you will write in alcoholic KOH, the reagent is alkoxide ion, which act as base due to its larger size and shows beta elimination. That is the, I mean, in and itself, board will accept this answer as a complete answer. Okay. Even if you write this still here. Now, next is if you have to understand this particular concept, then we will explain it. But even if you have very short time, then the few things that you have to write, you cannot forget is, in alcoholic agent, the reagent is alkoxide ion. You have to mention this word, which acts as base, this word. Okay. Now, due to its larger size is the next question. Why is alkoxide ion acting as a base? Its answer is due to its large size. Fine. Now, why does alcoholic KOH shows beta elimination? The answer is because the reagent is alkoxide ion, which is acting as base. It shows a beta elimination. So these two words are very important: alkoxide ion and act as base for this particular question. Whenever you read this question, in your head, you should have this phrase: alkoxide ion acts as base. Alkoxide ion, it acts as base. Just as in the case of thionyl chloride, why it is preferred method, then the phrase in your brain should be byproducts are gases. HCl and sulfur dioxide are gases. HCl and sulfur dioxide are gases. In the question that you have, why question again? Free radical halogenation of alkene is not done. It gives mixture of product difficult to separate. Now, these one-liners should be in your head whenever you are reading a question. Okay. So I hope you have started preparing that one-page why questions. And in those one-page why question, you will put up these questions only. No need to write the answers. Your answers are written. Okay, majduri nahi karna. You don't have to do labor. You have to study. So whenever you find yourself majduri karte na, labor karte, that means manual labor if you are doing it, then please stop and rethink how to do the same work a bit intellectually. So you write the questions, because questions should be there. The answer should be there in your brain, or otherwise it should be in the notes. Fine. So I hope you have written this. Now let us understand why it is happening. First of all, see this complete thing, whatever I'm writing here and explaining, you don't have to explain this when the question comes, but you need to understand how it is happening. Okay? I will take first of all alcoholic KOH. The important thing is that alcoholic KOH, what is the meaning of alcoholic KOH? When we say alcohol, we mean ethanol. Okay. So when we say alcohol, for example, if we say acid, then generally people mean acetic acid, vinegar jisme hota hai. Okay. So whenever we say alcohol, and people say na alcohol check kara lo iska, if someone is driving rush, and police inspectors, if they suspect that he has taken some kind of drug which is going to affect his mental state, then they will ask to take an alcohol test, right? So that alcohol is ethanol. Right? Now, what is ethanol? CH3, CH2, OH. Just like water. Just like water, it is a solvent. Okay, it's also this we are taking KOH. Is my voice breaking for everyone? Rabia, Tharif?
No, sir.
Okay, Khatun, there must be something from your end. So this is alcoholic KOH. Now in alcoholic KOH, this K plus ion is there, right? This from here, OH negative ion, complete dissociation will be there. Okay. Now, because of this complete dissociation, this alcohol will also dissociate and it will form O negative. Right? We will understand. See, when we have alcoholic KOH, then in that case, I will be forming alkoxide ion because we are reacting alcohol with a base. Now, in the presence of a base, it is going to act as acid and it is going to give O negative. So now this is my reagent. Okay, this particular thing is my reagent. If you draw the complete structure of this, it's going to be a large molecule. Carbon with 3 hydrogens, bonded to carbon with 1 hydrogen here, another hydrogen here, and then we are having O negative. Fine. Now let us look at a general haloalkene. We are having R group, something that is attached. Then we have the beta carbon with 2 hydrogens. Then we have the alpha carbon with 2 hydrogens. Let me take this only. Copy paste this. I will change the. Please don't draw this why I am drawing it. Okay. तो ध्यान से सुनिएगा अभी, प्लीज डोंट ड्रॉ इट नाउ. Here we are having R group. Okay. Now instead of O negative, we will have a halogen atom. Let us suppose we are taking bromine atom. We are taking bromine atom. So we are having alcoholic KOH, and let us look at aqueous KOH. So aqueous KOH will have water. So water will also break into H plus and OH negative. And KOH will also break into what? K positive and OH negative. So the only nucleophile, that means electron rich reagent that we are having, is OH negative. So from aqueous KOH, who is coming? From aqueous KOH, we have OH negative, the hydroxide. If you want the complete structure, it's going to be like this: H, O, and O with a negative charge. Okay. Now, please understand, here we are having both of these are electron rich. Here we have electron rich species. Now, in this substrate, there will be electron poor sites. There will be sites, there will be carbon atom or some other atom which is electron poor. So obviously this alpha carbon, which is the carbon bonded to bromine, this bromine will be pulling electrons because it is more electronegative, and this carbon will be generating a delta positive charge. That means a small positive charge will be generated because electrons is being pulled by bromine. Now this is going to be having delta positive charge, right? Another thing that will be having delta positive charges, since this carbon has delta positive, it has become a bit positive. It will pull electron from carbon atom like this, and this carbon atom will be pulling electrons from the hydrogen atoms. So when we are having the beta hydrogens, these beta hydrogens, they will be also getting some delta positive and delta positive charges. Okay. Now, the most positive charge, the highest positive charge is on alpha carbon. Alpha carbon will have the maximum partial positive charge. Hydrogens will not have that much positive charge. Carbon will have the most positive charge because it is directly attached with Br negative. It is attached with bromine atom. So that is why when there is an attack taking place, the most preferred site is for both of these things, alcoholic KOH or aqueous KOH, for alkoxide ion or the hydroxide ion. The best and the preferred position is this carbon atom. Is this carbon atom. Even for the hydroxide ion, it is this carbon atom that they should attack me. Fine. If I am only looking at the charges, is this understood? Yes or no? Please tell me. Fia, Hafsa, Mariam Khatun, Rabba, Tarif, Rabia, Shahid. The preferred site for attack should be the most positive carbon, right? That is the alpha carbon. Yes or no? Bolo,
Yes, sir.
All of you understood this now? Now, next thing that you have to look is the feasibility. That look at the sizes of both the reagents, hydroxide ion and the alkoxide ion. What do you think? The pink pathway is most possible or the blue pathway? Which is easy? Who will be having it easier to navigate and attack on the carbon atom? The pink one or the blue pathway? Tell me, guys. Logically, आप लोग खुद सोचिए बताइए. Look at the sizes now of the reagent and tell me which is easier. Yes, correct, Freya. What about others? मरियम खातून, तारीफ, रबा, राबिया. साइज देख के आप सोचिए ना, ऐसे ऐसे धीरे 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 करके जाएगा ना. चलिए वो भी हम आपको करके दिखा देते हैं. कैसी बात कर रहे हैं आप मरियम खातून? इतना बड़ा एटम तो आके अटैक कैसे कर पाएगा बताइए तो. कैसे यहाँ पे इतना इस तरह से घुस के अटैक कर पाएगा? कैसे कर पाएगा? बात समझ में आ रही है आपको मरियम खातून? That this blue pathway is not even possible because of the large size. मरियम खातून yes no बोलेंगे प्लीज. बोलिए आपने किस हिसाब से बोलिए ना, माइक ऑन कीजिए प्लीज. मरियम खातून, can you please tell me why did you say blue pathway is easier? Sorry. Yes, Mari, why did? ठीक है, नहीं सोच के बोला, कोई बात. ठीक है, सोचिए थोड़ा इसको, ऐसे इसको मूव करा के अगर हम लोग लेके जाएंगे, ठीक है, अगर मूव करा के लेके जाएंगे तो यू कैन सी दैट इट इज नॉट एबल टू अटैक हियर, राइट? बहुत ज्यादा रिपल्शन हो जाएगा बड़े बड़े ग्रुप्स के बीच. दैट इज व्हाई दिस ब्लू पाथवे, सिंस इट इज नॉट पॉसिबल, विल ड्रॉ अक्रॉस, and rather this alkoxide ion is going to attack on the hydrogen atom. Is going to attack on the hydrogen atom. Now I am removing all the red parts here because the attack is over. I don't need delta positive and delta negatives right now. So I'm removing these parts. Now please listen. So the blue pathway for alkoxide ion is to attack on hydrogen atom. Now, please understand, both alkoxide ion and hydroxide ion are coming with their own electrons to form bond. They don't need any other electron. What if the atom is bonded with any of the, if any one of them is bonded, it is going to break a bond, because oxygen in both the cases, alkoxide and hydroxide, is coming with their own electron. That is why if I follow the blue pathway, as soon as it attacks on this beta hydrogen, this beta hydrogen will give the electron density towards this bond. Okay. And this Br will leave. Please see slowly what is happening. First of all, we are having attack on the beta hydrogen. Then this beta hydrogen is giving electron density towards the carbon-carbon and making a double bond. This is the second step that is happening. In the third step, what is happening? The third step, what is happening? Since this carbon atom, देखिए, ये जो आपके पास beta carbon है ना, this beta carbon is losing a bond and it is forming a new bond. Now this alpha carbon, it was forming a new bond, right? That is why it is breaking the Br bond. That is why it is breaking the Br bond. Okay, and in the blue pathway, what happens? We will get a formation of alkenes. This R is as it is, followed by this carbon atom. It had two hydrogens. One of the hydrogen is taken away by the alkoxide ion. Now we have a double bond here, and this CH, in this CH2Br, the Br is left, and we are left with CH2. So we get alkene in that case. Now let us look at the pink pathway. In pink pathway, it is attacking on the carbon atom that's on alpha carbon. This alpha carbon already has. Now please forget all the blue lines. Okay. Try to forget all the blue lines. I'm showing both the reaction in a single picture. Please understand that blue lines are not present. Now the pink pathway is there. Completely new laboratory, completely new solution, completely new beaker. We don't have alkoxide ion. We have only hydroxide ions. Now in that case, what's going to happen? The pink pathway, the hydroxide ion, it is smaller in size. It can easily approach the carbon atom. It can easily approach the alpha carbon atom, to be very specific. And this alpha carbon already has 4 bonds. So it needs to break one of the bonds. And the bond it will break is the Br bond. And this pink pathway is going to give you, this pink pathway is going to give you this R will, nothing is happening at the beta carbon, so CH2 will be as it is. Now the alpha carbon, it has CH2 as it is, nothing is happening to the hydrogen, but instead of Br we will write OH because the Br has been replaced by OH. Now Fia, can you please turn your mic on?
Yes, sir.
What are you saying?
Sir, I understood that from blue pathway that it will attack the beta hydrogen, then the process starts. After that, that goes here, then because of the double bond formation, the Br also goes, it eliminates. But in the pink path, which is being attacked first, sir?
The first attack. So first attack is this one. This OH is attacking on the alpha carbon. And this is the second.
So in pink path, directly it attacks on alpha carbon.
Yeah, because it is small in size, no, that is why it can attack.
Okay, sir.
See, we have written about the size only, right? Here also, acts as base due to its larger size and shows beta elimination. Aqueous stage reagent is hydroxide, which is smaller in size and acts as nucleophile attacking on carbon atom, showing SN and forms alpha. Okay, please write this down. यहाँ पे लिख लीजिएगा due to larger size. This cross mark is there. Due to larger size. Done everyone, is please tell me.
No, sir.
Please let me know. Sir. All of you will write it very properly, okay? 1, 2, 3, and everything. If you want. This is the third step in the blue pathway. स्टेप का मतलब ये नहीं कि we can have 1 step 2 steps. एक ही बार में सारी चीजें होती. Atoms are very small, they act very fastly. There is no time consumed between the first 1, 2, and 3 in the blue pathway, and there is no time consumed in the 1 and 2 in the pink pathway.
Sir, in pink pathways, there is only 2 steps.
Alkoxide ion. Done. Please let me know once you're done, guys.
Done, sir. Done, sir.
Right. Right. Next, sets are full. Okay, sets are full. So it gives an idea about the formation of major product during elimination. During elimination reaction. What is the point? Sets are full. Please remember. Hydrogen is removed. from that beta carbon which has less number of hydrogens. Which has less number of hydrogens. Okay. Another way you can remember this is more substituted alkene. More substituted alkene is major product. In beta elimination. Just a second. एक second guys, I'm just more substituted alkene is the major product in beta elimination. ठीक है. And थोड़ा मैं यहाँ पे आपको steps बता दे रहे to write the product in beta elimination. ठीक है. What you have to do. So what you need to do is you need to follow these steps while you are writing. Okay, in order to not make any mistake. First of all, you will identify alpha and beta carbons. Second, count number of hydrogens. On every beta carbon. Sometimes you will have more than one beta carbon. That is, you have to count. You have to see how many beta carbons are there. Okay, and then you have to count the number of hydrogens on every beta carbon. Third thing that we need to do is remove halogen from alpha and hydrogen from that beta. From that beta carbon. Which has least number of hydrogen. ठीक है. Third thing, and after last thing is that make a double bond between alpha and beta कार्बन. ठीक है. अरे कार्बन मतलब आप लोग सारे बीटा में बना दिया, अल्फा एंड बीटा. Okay, between alpha and beta, जिसमें जिससे आपने from where you have removed hydrogen, है ना, कोई चांस नहीं था. From where alpha and beta from, क्या लिखे हम इसमें बताइए. तो एक तो लिखा हुआ नहीं रहता है, सारी चीजों को हम लिखाते हैं. Make a double bond between alpha and beta, alpha and that beta. Beta carbon from which alpha and beta carbon from which hydrogen is. ठीक है. So you have to make between alpha, alpha तो एक ही रहेगा, बीटा दो हो सकते हैं. तो उस बीटा से डबल बॉन्ड बनाना जहां से आपने हाइड्रोजन को रिमूव, from where you have removed the hydrogen atom, that beta carbon. Now let me give you an example. Please don't write this. Okay, you have 1, 2, 3, 4. You'll look at the reagent alcoholic KOH. So obviously this is elimination reaction. Okay. Now tell me which is the alpha carbon, guys, in the chat. Which is the alpha carbon? Mariam Khatun, थोड़ा आप ध्यान दीजिए क्या हो गया आपको. Thank you very much. Yes. पिया सही है, तारीफ सही है. आपने वो नहीं अल्फा आइडेंटिफाई कर लिया. राबिया क्या वो जवाब नहीं देना आपने. राबिया रबा आंसर करें ना. Yes. Third carbon, very good, Hafsa. So third carbon is the alpha carbon. Now, what are the beta carbons? Please remember, beta carbon is directly attached with alpha carbon. So which carbon is the beta carbon in 1, 2, 4? The remaining carbon, which one is beta? The remaining carbons, which one is beta? Yes, Mariam Khatun, very good. Yes, Fia, very good. Others, please identify. Alpha, yes, Hafsa, Tarif. Tarif, there is one more beta carbon. Try to identify that also. Yes, correct, very good. Rabah, Rabia, no answers from you guys. Rabah, नहीं समझ में आ रहा क्या? Rabia, Rabah, tell me ना. Yes, thank you very much. Okay. So this second carbon and fourth carbon, both of these are beta carbons, right? This is also beta carbon, and this is also beta carbon. Now, how many hydrogen in the blue one? Tell me, guys. How many hydrogens in the blue one in the chat? How many hydrogens in the blue one? No, Khatun, once again, please try. भूल गए खातून, आप हाइड्रोजन काउंट करना भूल गए. कैसे चलेगा ऐसे का? ब्लू वाले में बताइए. ब्लू वाले में पिया सही है, वेरी गुड. तारीफ सही है. अच्छा ठीक है. रेड वाले के लिए सही है प्रकार. यस ठीक है. सो ब्लू वन इज हैविंग 3 हाइड्रोजन and red one is having, tell me guys, red one is having, yes Khatun ab sahi hai, very good. 2 hydrogens in the red. Okay, so which one is having less hydrogen? Less hydrogen किसके पास है? less इतना तो रोज बोलना पड़ता है हमको. least hydrogen किसके पास है? blue या red? blue या red? blue या red, which one is having less? come where you are having less hydrogens? आंसर करें ना आप लोग. लिखिए मत, अभी चैट में आपका हाथ रहना चाहिए. आंसर करें. which carbon is having? तारीफ करेक्ट. yes खातून करेक्ट. yes very good. red. ठीक है. thank you very much. now what we need to do, you are going to remove the bromine from the alpha carbon and एक हाइड्रोजन कहां से निकल जाएगा? from the beta. which beta? the red beta. so you will form इस तरह से. ठीक है. now we don't show hydrogens, so that is why you don't need to remove. actually you will just make everything as it is in the bond line structure. right? So this was your alpha carbon from where bromine has been removed. This is your beta carbon from where halogen has been removed. We will make a double bond between them. This is the major product. Okay. Now, if they ask you all the products, then you will have to write one more product, which will be the same thing as it is. And now the double bond between will be between alpha and the other beta carbon. Okay. So this is minor product. You don't have to worry so much about the minor product. Okay. So please write this down. All of you understood this? Yes or no? Please tell me. खातून कोई और क्लास भी हो रही है क्या आपकी? Yes, Mariam Khatun. You guys can make the products now. सवाल दें अब आपको? हाँ या ना बताइए. ठीक है. दूसरी चीज हम बोलेंगे सबको. What you need to do is you need to identify alpha and beta and the number of hydrogen. ये करना आपके लिए बहुत जरूरी है. If you are not going to do this, फिर आंसर्स आपके गलत आने लगेंगे. ठीक है? Write a few questions. तो ये भी देख लीजिए अगर सेम हो तो क्या करना है. Let's suppose we are having iodine here. Okay. Now this is my alpha carbon. Now this is my beta carbon. This is also beta carbon. This is also having 3 hydrogens. This is also having 3 hydrogens, and this one is also having 3 hydrogens. Now in this case, since the number of hydrogens are same, I mean, there is no choice, right? We have only one choice. क्या choice है आपको? Choice है आपके पास that you remove from alpha, you will remove the iodine for sure, and from any one of the beta carbons you can remove the hydrogen. So here also you are going to get propene, and if you write another product like this, now this is not that different, but this is also propene. Okay, this is also propene. बस हम लोगों ने इसको पलट के रख दिया है ना. ठीक है. So you are going to get only one product when you have the same. बस ये करना बहुत important है. If I don't know like how much your brain is saying that no, you know it, don't do it, don't try it, don't try it, don't try it. You will tell your brain, no, I have to write. Product making is not the major thing here. Writing alpha carbon and identifying the number of beta hydrogens is more important. Identifying number of beta hydrogens is more important. Identifying number of beta hydrogen is ये बात बिल्कुल दिमाग में बैठा लीजिए. Product important नहीं है आपके लिए. ठीक है. चलिए. Write some other questions now.
Sir, in this reagent, aqueous NaOH will come or KOH will come?
What? Sorry.
In this reagent, aqueous KOH or NaOH will come?
You tell me what reagent will come. We are done with the topic.
Sorry, sir.
You tell me what reagent will come.
No, sir. I'm asking you, sir.
I understand your answer, but we are done with the topic now. Yeah. Look at the notes and tell me what reagent
Yeah,
will be there
so
in
that
beta.
won't be applied here.
You're saying?
Sir, I'm asking you that aqueous KOH will be applied or it won't be applied, sir.
See, I'm asking you the same. See, we are done with the topic now. Yeah. You tell me what I have taught.
Yeah, you just thought the difference between 2 and how it acts
So,
because of
okay, so
its
tell me.
larger size, smaller size.
Fine. So tell me, in aqueous KOH, what is happening? Elimination. When we use aqueous KOH, then what reaction?
SN reaction.
What reaction?
SN reaction.
SN.
Nucleophile.
I am asking, beta elimination happens. Does beta elimination happens when you have aqueous KOH?
No, sir.
So you tell me, will that be used in elimination reaction?
No, sir.
See, you got your answer, है ना? बुरा मत मानिएगा, ठीक है? नहीं, हम बता रहे चीजों को, जैसे मान लीजिए हम हमेशा नहीं रहेंगे ना, ठीक है? तो कई बार आपको चीजों को खुद से समझना पड़ेगा और थोड़ा सा भरोसा रखिए कि आप जो समझ रही हैं वो सही है। वो मतलब हमको ये लगता है कि आपके साथ दिक्कत ये होती है कि आप बार बार ये कंफर्म करना चाहिए कि हम सही समझ रहे हैं, है ना? आपको कंफर्म करने का मन करता है, राइट? या इज दैट द केस? हाँ जी,
Yes, sir.
है ना? तो थोड़ा भरोसा रखिए अपने आप पे, है ना? और गलती करने से मत डरिए, अभी क्या दिक्कत है, अभी तो पढ़ रहे हैं ना, ठीक है? अभी गलती करने से मत डरिए। Try to write the answers for these. Now, I will give you like 4 minutes, no matter how many questions you do, not more than 4 minutes. Okay. Now, what I will suggest you guys is that don't write the product first. Please don't write the product. Okay. I need to see the identification of alpha carbon. I need to see the identification of the number beta carbons and the number of hydrogens. Beta carbons and the number of hydrogens. Okay. Try to put the effort there. ठीक है, भले ही आपने प्रोडक्ट नहीं लिखा, नो मैटर, डजंट मैटर, आप सिर्फ ये कम से कम कर लीजिए कि अल्फा कार्बन आइडेंटिफाई कर लीजिए एंड देन आइडेंटिफाई द बीटा कार्बन एंड देयर नंबर ऑफ हाइड्रोजन्स इन द बीटा कार्बन, ठीक है? एंड ट्राई टू बी प्रिसाइज देयर, ट्राई टू बी केयरफुल व्हाइल यू आर आइडेंटिफाइंग अल्फा एंड द बीटा कार्बन, है ना? यू विल मेक मिस्टेक देयर। चलिए, टाइम हैज स्टार्टेड, है ना? Yes, above first one is correct. Now you can start writing the product. No, sixth one में देखिए, where you have written one hydrogen, वहाँ पे कितना hydrogen? Look at the number of bond, double bond भी है ना वहाँ पे रबा? रबा, can you please turn your mic on?
Yes, sir.
तो कितने hydrogens होंगे वहाँ पे?
No hydrogen, sir.
How many? Sorry?
No
How many
hydrogen.
hydrogens?
It will
No,
be only carbon.
zero बोल दिया कीजिए भाई।
Yeah, sorry, zero.
ठीक है, उसके बाद सेवेंथ वाले में एक तो 2 हाइड्रोजन है और दूसरे वाले में जहाँ पे 2 CH3 लगे हैं
No hydrogen. Like zero hydrogen.
जीरो। हाँ ठीक। अच्छा अब बताइए कहाँ पे अटैच होगा, 2 हाइड्रोजन में या 0 हाइड्रोजन में, डबल बॉन्ड कहाँ बनेगा?
2 पे.
हाँ। और 6th वाले में 3 हाइड्रोजन पे बनेगा या फिर 0 हाइड्रोजन पे?
3 पे. Sorry,
है ना?
0. 3 पे.
नहीं 3 पे, 0 पे क्यों नहीं बनेगा बताइए? अब जब हाइड्रोजन है
0
ही
पे.
नहीं वहां से, हाइड्रोजन है ही
हाँ
नहीं
पे
तो निकलेगा
हाइड्रोजन
क्या?
है सो हाँ.
हाँ क्या निकलेगा वहां से, है ना, कुछ निकलेगा ही नहीं। ठीक है, दैट इज वाई थर्ड वाले राइट द प्रोडक्ट्स आइडेंटिफिकेशन सही। चलिए ऑल ऑफ यू सेंड वॉट एवर यू हैव डन, प्लीज सेंड मी वॉट एवर यू हैव डन। ठीक है, इस सवाल के जवाब तो हम बाद में करेंगे, लेकिन नंबर ऑफ आप लोग भेजिए हमें। ठीक है, सेंड मी वॉट एवर यू हैव डन टिल नाउ, आइडेंटिफिकेशन ऑफ अल्फा बीटा सारा कुछ। एक और रिएक्शन कराना था, शायद वो नहीं हो पाएगा, वुड्स रिएक्शन भी हमने लिखा हुआ था टॉपिक में, लेकिन आज शायद वो नहीं हो पाएगा। रिएक्शन विद मेटल्स, क्या कोई बात नहीं, थोड़ा एक क्लास ज्यादा नहीं जाएगा क्या? मरियम ने भेजा है। मरियम आप एक सेकेंड, आपने सी 4th वाले में आपने हाइड्रोजन नहीं लिखा है मरियम, कैसे चलेगा यार? ये चीजें हम बोल रहे थे तब से, प्रोडक्ट नहीं बनाना, पहले आप हाइड्रोजन तो लिख लेते हैं। मरियम खातून, मरियम 4th वाले में लिखना है ना आपको ना, बीटा कार्बन कौन कौन से वो लिखिएगा। ठीक है, 5th वाले में आइए, कीप योर माइक ऑन, 5th वाले में आइए। ठीक है, 5th वाले में अब देखिए अल्फा और बीटा के बीच में बनेगा ना, आपने डबल बॉन्ड कहाँ बना दिया है? अल्फा और बीटा के बीच में बनेगा ना मरियम खातून। ठीक है, और दूसरे, ठीक है एक बार समझ में आ गई। उसके बाद आइए 6th वाले में, 6th वाले में जो आपने बीटा कार्बन है, बेंजीन वाला बीटा है मरियम खातून, वहां पे कितने बॉन्ड्स हैं उस कार्बन पे? कितने बॉन्ड्स हैं? जोर से बोलिए, जोर से। हाँ कितने बॉन्ड्स हैं, जोर से बोलिए, किसी को आवाज सुनाई दे रहा, क्या बोल रही है बता दें। एनीवन हु कैन लिसन मरियम खातून? द बेंजीन बीटा, बेंजीन वाला जो बीटा कार्बन है ना, क्वेश्चन नंबर हम आपको बता रहे हैं, क्वेश्चन नंबर इज 6th क्वेश्चन। 1 बीटा इज CH3 और दूसरा जो आपने CH2 लिखा है ना, उसमें CH2 होगा, वो देखिए जरा कितने, दैट कार्बन इज हैविंग हाउ मेनी बॉन्ड्स? सॉरी मरियम, अरे नहीं CH3 नहीं होगा ना। अब सवाल तो सुनिए यार, मेरा सवाल तो सुनो। बेंजीन में जो बीटा आपने लिखा हुआ है, जहां CH2 लिखा है, आप टेल मी हाउ मेनी बॉन्ड्स दैट कार्बन इज हैविंग, द नंबर ऑफ बॉन्ड, विजिबल बॉन्ड्स कितने हैं वो बताइए आप। तीन बॉन्ड है वहां पे, फिर से देखिए कितने बॉन्ड, डबल बॉन्ड नहीं है वहां, कितने बॉन्ड्स हो गए? तो हाइड्रोजन कितना होगा वहां पे? हाँ फिर CH2 कैसे लिख दिया आप? सुनिए यहाँ पे कितने 0 हाइड्रोजन है। ठीक है, चलिए अब एक चीज ध्यान रखिएगा आप लोग, ऑल ऑफ यू गाइस, एंड फिया सिंस यू हैव सेंट मी द आंसर्स प्लीज लिसन, यू हैव मेड आल्सो द प्रोडक्ट ना, ध्यान सुनिए। इफ देयर आर, अच्छा बीटा कार्बन से क्या निकलता है फिया? अल्फा से निकलता है हैलोजन, बीटा से क्या निकलता है? बीटा से व्हाट इज एलिमिनेटेड फ्रॉम द बीटा?
हाइड्रोजन सर।
जब 0 हाइड्रोजन है तो क्या निकलेगा? यस फिया,
यस सर, बट
कुछ नहीं निकलेगा, है ना? ध्यान से थोड़ा देख लीजिए आप लोग, व्हेन यू हैव 0 हाइड्रोजन तो 0 कुछ निकलेगा ही नहीं, दैट इज व्हाई दिस बीटा विल बी 3 हाइड्रोजन और यहां से निकलेंगे फिर। ठीक है, सो द प्रोडक्ट विल बी, और सेम चीज आप देखिए 7th वाले में भी डबल बॉन्ड ऐसे बन जाएगा। 7th वाले में हियर यू आर गोइंग टू हैव हाउ मेनी 1 2 3 बॉन्ड्स, सो 1 हाइड्रोजन, और यहाँ पे you will have 0 hydrogens, right? So you are going to make the product like this. The Br will be eliminated from the, oh my god, my bad. यहाँ पे hydrogen alpha, यहाँ पे हमने देखना होगा, sorry, this is alpha. इस बीटा के पास कितने हाइड्रोजन है? 2 हाइड्रोजन है. यहाँ से 0 है तो इसको तो देखना ही नहीं है. We cannot remove any hydrogen from here, right? So it will be removed from the 2 hydrogen beta carbon. इस तरह से. ठीक है. उसके बाद Hafsa, can you please turn your mic on? Hafsa, can you please turn your mic on? Hafsa, can you please turn your mic
Yes,
on?
sir.
Yeah, thank you. Now, in the third one, ठीक है, तीसरे वाले में देखिए, what you have, I don't understand what you have done. Once you remove the beta bromine, this will also be removed, ना? ये तो bond है सिर्फ. This is not carbon atom, ना? Carbon, this is a bond. Br हटा दिया, bond अकेला क्या कर रहा है? Sorry, my bad for the Hindi. What is the bond doing on its own? You have understood what I'm trying to say? Look here, what we have done. There is no bond here. Got it, Hafsa?
Yes, sir.
ठीक है. Now you have removed the bromine from this carbon atom, and then you are going to attach. Now these are the beta. This is alpha. This is the beta, na? So you'll either attach from here or here. Got it?
Yes, sir.
Okay. Next, you have identified carbon, 3 hydrogen. That's fine. And alcoholic and you don't have to write the number of hydrogens on the alpha carbon. See, did I write the number of hydrogens on the alpha carbon?
No, sir.
You don't have to write it. Okay, it will be getting that's why you are getting confused. One hydrogen you made a double bond there. Huh? Okay, so you understood the mistake, Hafsa?
Yes, sir.
Okay, so because you wrote here 1 hydrogen and then you made a double bond like this, right? Because it was having 1 hydrogen. Correct?
Yes, sir. Yes, sir.
Okay, so that's only happening because you're writing the number of hydrogens on alpha carbon. If you don't do that, make the